The third section of Unit 5 is solving trigonometric equations. So the purpose of being able to use these identities and to change equations and verify the identities in the last two sections was so that you could prepare yourself for solving trigonometric equations. And solutions that solutions are values that make the equation true. Not all equations have solutions. You've run across that before in other problems in algebra. And you always must check your solutions. There might be extraneous solutions. So there are infinitely many solutions that are possible, but for this class we're only going to focus on what you see in the unit circle. We're only doing this in radians. We are not doing this in degrees. So you're going to find all the solutions in the interval from 0 to 2 pi, but we're not going to include 2 pi because it's the same as 0. And there are some different techniques here as well. So the first example I'm going to show you is how to collect terms. You would have this in algebra if you were using just x. The only thing I'm replacing x with the word sine x. So my equation is sine x plus the square root of 2 equals negative sine x. When I collect terms, I'm going to get sine x on one side of the equation, so I subtracted sine x and got negative 2 sine x. I want to solve for sine x, so I have to divide by negative 2. So I get sine x equals negative square root of 2 over 2. Now I start thinking about this. Sine is negative in the third and fourth quadrant, so I wrote that down so that I don't forget that. I only want the answers in the third or fourth quadrant. So I start thinking about that. So the angle that it has to be is going to be 5 pi over 4 and 7 pi over 4. And there are two ways to check your answers. One of the ways I do this, and I've done this before, is I'm going to store 5 pi over 4 for x. And then type in my original equation, which would be sine plus the square root of 2 and the other side of my equation was negative sine x. If those two sides equal each other, then I did it correct. And I would check my other one as well. Another way to check your answer, and we haven't talked about much in Culpeper before, but I could graph the left side of the equation, so my left side of the equation, and my right side of the equation. And when I graph those two, wherever they intersect is going to be the solution. But I'm only looking at from 0 to 2 pi. So my minimum is 0, my maximum is 2 pi. And when I typed it in here, I literally typed in 2 pi. I can change my increments. I can change this to pi divided by 6 or whatever I want it to be. So now when I graph, there's the left side of the equation. There's the right side of the equation. You can see there are 2 points of intersection. Second trace, intersect. I just hit enter 3 times. It gives me the first point, which is 3.92699908. And I said my answer was 5 pi over 4. So let's see if 5 pi over 4. Yep, there it is. And I would check the other one as well. My next problem I have, I'm going to show you how to solve it by factoring. So sine theta times tangent theta minus sine theta equals 0. I can factor out the greatest common factor, which is sine theta. And on these problems, you do not have to justify each step like we did in the last ones, but I have to be able to see your process. They have to be, each step has to be a valid step. Once I have it factored, I can set each factor equal to 0, just like we would have done in an algebraic expression. So the first equation, sine theta equals 0, well, sine theta equals 0 at 0 and pi. Tangent theta minus 1 equals 0. So I'm going to set tangent theta equals 1. And tangent theta equals 1. It's got to be positive, so it has to be the first quadrant and the third quadrant. So the answers are pi over 4 and 5 pi over 4. So now you're seeing why you really have to know your unit circle. My next example is a factoring, but it's factoring something that looks like a quadratic. So I have 2 sine squared theta minus sine theta equals 0. If I want to factor that, it has to equal 0 first. So I subtracted the 1 from both sides. Now, to make it easier to look at, what if I replace the sine theta with x? So I get 2x squared minus x minus 1 equals 0. I can factor that from algebra 1. But then I'm going to remember to put the sine back in. So I'm going to replace the x's back again with sines. And be very careful. Double check your factoring to make sure that you factor it correctly. 2 sine theta times sine theta is 2 sine squared. 2 sine theta times negative 1 is negative 2 sine theta. 1 times sine theta is a positive 1 sine theta. So negative 2 plus 1 is my negative sine theta. That's where I get that. Positive 1 multiplied by negative 1 is my negative 1. I set each factor equal to 0. So I get 2 sine theta plus 1 equals 0. And I skipped a lot of steps on this one. Let's go ahead and erase this, because I do not want you to skip the steps. So 2 sine theta plus 1 equals 0. So I get sine theta equals negative 1/2. Sine is negative in quadrant 3 and quadrant 4. So I have to think of those 2 quadrants only. So I get theta is equal to 7 pi over 6 and 11 pi over 6. Set the other factor equal to 0. And I get sine theta equals 1. Sine theta is equal to 1 and theta equals pi over 2. So there's all my solutions. My next example is going to use an identity. These are the ones that students tend to mix up the most often because they're not sure where to go. And I could do this a lot of different ways. The way I'm going to show you is I feel the easiest. I'm going to first divide by cosine squared. I'm not going to subtract. I'm going to divide. And I could. There's a method where I could subtract and do some identities. To me, this is just the simplest. So when I divide by cosine squared, I get sine squared over cosine squared equals 3. I can replace sine squared over cosine squared with tangent squared. Take the square root of both sides, and I get tangent x equals plus or minus the square root of 3. So now my answers have to be first, second, third, and fourth quadrant. So the way I think of this, tangent is sine over cosine, and I want a square root of 3 on top, so I want something square root of 3 over 2 over 1/2. And I know sine is the square root of 3 over 2 at all the multiples of pi over 3. So my answers are going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. 2 more examples. These multiple angle examples, students struggle with the most. And I do understand why, so I'll try to explain it as best as I can. I want to find all answers. I want to find x between 0 and 2 pi. Well, I'm given 2x, so I have to think differently. So I know tangent to x equals negative square root of 3 I want second and fourth quadrant is when tangent's negative. So I get 2x is equal to 2 pi over 3 and 5 pi over 3. And when I divide that by 2, 2 pi over 3 divided by 2 gives me pi over 3. 5 pi over 3 divided by 2 gives me 5 pi over 6. Divide by 2, divide by 2, divide by 2. Well, the problem I have, these are only the first and second quadrant. I need to go all the way to the fourth quadrant, so I need another set of numbers. Coterminal with 2 pi over 3. So 2 pi over 3 plus 6 pi over 3. 2 pi over 3 plus 6 pi over 3 is going to be 8 pi over 3. Divide that by 2. I get 4 pi over 3. 5 pi over 3, coterminal with that, add 6 pi over 3. I get 11 pi over 3. 11 pi over 3 divided by 2 will give me 11 pi over 6. That is where I stop, because if I go any further, I'll be past 2 pi. In my last example, I've got 3x. But remember, once again, I only want the x between 0 and 2 pi. So with this one, I'm going to combine like terms. 10 sine x minus 8 sine x will give me 2 sine 3x. Let me say that again. 10 sine 3x. Subtract 8 sine 3x gives me 2 sine 3x. Add 2 to both sides, and I get a 1. I'm going to divide by 2, so I get 2 sine x, messing this up, sine 3x equals 1/2. Sine is positive in the first and second quadrant, so I know my answers have to be there. So first quadrant I get pi over 6. Second quadrant I get 5 pi over 6. When I divide by 3, same thing as multiplying by 1/3. I get pi over 18 and 5 pi over 18. Well, what's happening is I actually have a lot more. 5 pi over 18 is still, I mean, it's only in the first quadrant. So I need to go further. So let's find coterminal. Pi over 6, coterminal means I'm going to add 12 pi over 6. I get 13 pi over 6. Divide by 3, 13 pi over 18. 17 pi over 6 I got because I added 12 pi over 6 to 5 pi over 6. Divide that by 3, and I get 17 pi over 18. Well, 17 pi over 18 is still not far enough. I can go, it's not all the way up to 2 pi. I've got to go further. So 25 pi over 6. I add 12 and 13, I get 25. Divide that by 3, get 25 pi over 18. 17, if I add 12 to that, gives me 29. 29 pi over 6 divided by 3 will be 29 pi over 18. So this one actually has 6 answers. Several years ago, one of my students came up with the pattern. They started noticing a pattern with this. If I put a 2 in front here, I had 2 sets of answers. If I put a 3 here, I have 3 sets of answers. And it worked well for them. So the multiple angles takes a little bit to get used to, but that's how you solve trigonometric equations.